Yo, what's going on, guys? Your everyday math tutor here. And before I begin, I just want to apologize. My voice sounds like I'm sick, and that is because I have allergies right now. I've been sneezing like a lot throughout the day, and yeah, it just sucks. But I can still make these videos, so might as well. So, anyways, let's start with this problem. In the figure, BC is parallel to DE. AD is equal to 10, so we'll write that down immediately. So let's do it with the light blue. AD is equal to 10, so this entire section is 10. AB is 6, so just this side, A to B is 6. And BC is 4. Find DE. So the first thing that you might be thinking is, okay, so there are two things that we might be thinking so far. I know some of you guys who are really experts at math have already or could already see where we can go with this, but there are two things that pop up to maybe somebody who's just starting to learn the parallel lines and proportional parts. So there are two theorems that come to mind here. There is the triangle proportionality theorem. What that says is that if there are two lines that are parallel, or at least, or here we go. If a line is parallel to one side of a triangle and intersects the other two sides, then it divides the sides into segments of proportional lengths. So here we have BC that intersects AE and AD, and DE intersects AE and AD, right? These, I'll color it green. These are the two parallel lines. But the triangle proportionality theorem says that AB over BD is equal to AC over CE if BC is parallel to or is parallel with DE or to DE, doesn't matter. But we can't use BC's value because the triangle proportionality theorem doesn't allow us to use that. So we can't use the triangle proportionality theorem. Okay, so that's right off the bat. The second one that we might be thinking is the triangle mid-segment theorem, where the mid-segment is half the base, basically, of the triangle here. But right off the bat, again, BC is not the mid-segment, because if A to B is 6, the total is 10, so that means that BD has to be 4. So that's, we can't use the mid-segment or the triangle mid-segment theorem, where BC would be half DE, basically. So what do? Well, we're going to go ahead and use the bigger triangle, which is this one here, and make it proportional to the smaller triangle that's right here, that I'll shade in here. Okay, so maybe if I leave it like this, or maybe if I color it a little better, we'll use this smaller triangle to solve for the bigger value of DE here. So we'll color this in here, and we can start. So first things first is we can say we look at the values that we have. So AB, and one that is proportionate to AB would be AD. And AD we know is going to be 10. But we'll keep it AD just to see what sides are proportionate to each other or proportional to each other. And BC, oh my God, that just sucks. Trying to breathe in through my nose. I have to breathe through my mouth. It's just terrible allergies. But BC is proportional to DE. Okay, so we do this because the two theorems, the triangle mid-segment theorem and the triangle proportionality theorem, just do not work. So we have to use just regular proportional theories. Okay, so AB we do have a value for, which is 6, and AD we have a value for 10, BC we have a value for 4, and DE we just don't have right now. But we can cross multiply to get 6DE is equal to 40, and DE is equal to 40 divided by 6, or 20 divided by 3, which I believe is like 6.66667, I believe. Let's look at our calculator. 20 divided by 3. So yes, it is 6.6666667, but we're just going to keep it as 20 divided by 3. So DE is 20 divided by 3. So that's how you do that problem. Use regular proportions. We don't use mid-segment because, first of all, BC is not the mid-segment. We already established that because AB is 6 and BD or DB, doesn't matter, is 4. So this is 4 here. So that's BC is obviously not the mid segment. And we can't use the triangle proportionality theorem again because it says that we only basically could use, let's see if we could use a different color. Let's change the green to something else. Let's try red. The triangle, wow, I can't even take that out. But triangle proportionality theorem says we can only use these values on the sides and we can't use the mid segments. The mid segments is just what's going to be possibly what we use for the triangle proportionality theorem, but we don't have any values here, so we use regular proportions. We'll have another video tomorrow on triangles. Basically, all of this is just a review for myself as well, but I'm putting it out there for you guys. Remember, one way you could actually remember things is if you actually teach it to other people. If you teach it to other people, you might be able to remember a lot more. So hopefully that's some advice I can give to you guys and you guys could use. I'll see you guys in the next video. Hopefully you guys could give this video a like and a subscribe. Obviously, I'll try to post every day. And I'll see you guys in the next video.